Recording in progress.
Right. So good morning, student. It's 7:30. Let's start. Although we have only 57 student, so half of the batch is only available. Anyway, that let's start. Right. So one student, please confirm the hearing of my voice and the visibility of my screen.
We can hear you, sir.
Yeah, please confirm. Okay. Right. Thank you. Thank you so much. Right. So what we have done so far, and this is your syllabus, and we have basically analyzed moving system, and the first part is for that one, and we have covered two learning outcomes through this particular thing, and we have learned about moving system and kinematics equation and Newton's law, force, momentum, impulse, work, and energy, and then conservation of energy, kinetic potential energy. And so power and efficiency machines basically that you can apply everywhere. So I don't want to talk that kind of things, right? It's a mechanical part, right? So today we are moving to a new section, which is fluid mechanics. The section that is so called fluid mechanics. So in the case of fluid, that there's a new name for you, fluid. So fluid, it's a branch. Fluid mechanics is a branch of physics, which is concerned with the mechanics of fluid. The mechanics of object. For that, we have learned about boxes and moving vehicles, this type of thing. And now we are talking about mechanics of fluids. So fluids mean liquids and gases, and also another so-called plasma. So plasma, you don't know. It's okay. You don't need to know, right? The other one is liquid and gases. So it's a behavior of liquid and gases and plasma. To explain this one, I just consider a liquid. That's okay. Make explain can lazy and accommodate the mang liquid tamai gun. නමුත් කන්ඩෙන්ස් ගෑස් එකක් ඒකටත් මේ හරියනවා ප්ලාස්මා කියන එකටත් මේ හරියනවා තියෙනවා පොසිටිව් නෙගටිව් අයන් ගෝල්ඩ් එකක් වගේ අයන් ද්‍රවයක් වගේ නිකන් එහෙම ඔයාගේ නිකන් දැනගන්න එහෙම එකටත් මේක ඉතින් හරියනවා මේ ඉගෙන ගන්න ටික mainly that we are focusing on liquid. This is where that you have to consider sort of applications. Flow of liquid you need to consider, and then pressure of liquid, that is really important in a mechanical system. ඉතින් මේ වගේ ගොඩක් දේවල් තියෙනවා ඔයාට ඉගෙන ගන්න. Right. So let's move to it. So first we have to define the density of liquid, right? The density of liquid, and we basically define density as its mass per unit volume. එහෙම තමයි අපි ඉගෙන ගන්න තියෙන්නේ. ඒකක පරිමාවක ස්කන්ධය. It's a mass per unit volume. That is a density. And then the important word is pressure. The pressure is defined as, can anybody tell pressure කියන්නේ මොකක්ද? පීඩනය කොහොමද අපි අර්ථ දක්වලා තියෙන්නේ? So Yenuka Sangeet, are you there? Then Madhumal.
Yes, sir.
Right. So can you define pressure,
ඒක
Madhumal?
ඒකක වර්ගඵලයක් මත ක්‍රියා කරන බලය.
Balaya. Right. So when I define this in English, so the balaya mean force, then varga palaya, it's a area. So ekaka mean unit, right? So then it can define very easily force per unit area, right? So what is Madhumar? Force per unit area.
Force per unit area. Okay, sir.
Unit area, right? So density is mass per unit volume. ස්කන්ධය ඒකක පරිමාවක් මත. එතකොට pressure, force per unit area, right? So you can define these things, right? Now you can very easily define, right? Density is mass per unit volume, and in the case of pressure, this is force per unit area. So what we are doing here, normally in this type of equation, we equal this part into one. අපි මේ වගේ එකක් define කරනකොට හැමතිස්සෙම කරන්නේ අපි යට තියෙන එක එකට equal කරනවා. So then if it is 1, then this one equal to this part. This one equal to this part. Right? Hope it is clear for you. Then if you want to define this one, so what you have to do is that once we put this one as 1, then this one equal to this one. Right. Let's define like that one. Then density is mass if this one is 1 per unit volume, right? So here we define pressure is force per unit area. This one is 1 now per unit area. ඒකක වර්ගඵලය ඒකක පරිමාවක්. එහෙම වුණාම අරක මේකට equal වෙනවා. අපි දන්නේ නැති එකක් හිතමු, if we have an unknown equation, A equal B divided by C. So how to define A? We can define A is very easily. A of any object we can say is defined as B of unit C. B of unit C. A is B of unit C. A කියන්නේ B unit C එක. අන්න ඒ වගේ තමයි මේක define කරන්නේ. Right? Is it clear? Right. So you can write this one.
Recording stopped. Recording in progress.
Right. Is it clear? Make a පැහැදිලිද? Right. So what we will consider in fluid mechanics? Then අපි mechanics නේ කතා කරන්නේ. So you have to understand that what we are going to concern, what we are going to learn in the case of fluid mechanics. So we are going to learn mechanics of fluid. So mechanics, it might be movement, might be once it's available statically, and also as apply force on the liquid. How to pronounce this one? Which one? Fluid? Or that A equal B, 1C equals 1, I guess. One student asking this question, but how to pronounce this one? It might be fluid mechanics, right? Right. So we are going to learn the mechanics. So it's been sort of movement and some parameters involved. And also what happens if we apply certain force to the fluids. So this is what we are going to learn in fluid mechanics. You all know that certain characteristics of fluids available. Fluid ගත්තාම fluid වලට තියෙනවා මේ characteristics. We have learned this one in grade 7. The important characteristic is that, can someone say, ද්‍රවයක ලක්ෂණ කියලා අපි නෑ ඉගෙන ගත්තේ මේක පුංචි කාලේ. ද්‍රවයක තියෙන ලක්ෂණ. කාට හරි මතකද ඒක? පොඩි කාලේ ඉගෙන ගත්ත එක. So let's get Aditya Sevandi.
Yes, sir.
Right, Aditya. Then let's get Kasun Pradeep.
Yes, sir.
Right, Kasun and Aditya. Right. So Kasun, where are you?
I'm from Ratnur.
Ratnapura.
Yes, sir.
Right. So what is your school?
Ravanashna School. Good.
Right. මේ පැත්තේ නේද දන්නේ?
Oh, sir.
සබරගමුවේ.
Yes, sir.
Right. And how about Aditya?
I am from Kurunagal, sir.
Kurunal, right. So what is your school?
Nugewel Central College.
Right. Really nice one, right? So very famous and good for sports and always having sort of good results in advanced levels, right? Right. So how many of you entered to the university in your particular year? ඊදෙනෙක් university එකට enter වුණාද?
25 students, sir.
25 students, right? That's good number, right? Compare, because there are a lot of schools there in Kurunnagar. So 25 is big number compared to that the school status, right? So Aditya, now the question is that we have a certain characteristics of fluid. So let's consider only the liquid, right? We don't need to consider about gas and also the plasma. So plasma, as I said, that you don't know, right? It's an electrical charge liquid, I can say. It's having sort of ionic behavior, but you don't need to understand this. Right. So what happened? What happened in the case of very nice things we have learned in, I think, grade 7, the shape of liquid. Shape of liquid. Right. So what is the shape of liquid? What is the shape of liquid, Kasun and Aditya?
Liquid has no shape, sir.
No shape. Right. Liquid basically without any shape. But we have defined the shape of liquid in grade 7. Right? There's no defined volumes. There's no defined shapes. But the shape of the liquid depends or depends on what?
අදාළ භාජනයේ හැඩය ගන්නවා.
හරියට හරි නේද? අපි එහෙම තමයි ඉගෙන ගත්තේ නේ. ද්‍රවයක් භාජනයේ හැඩය මත shape එක depend වෙනවා නේ. So what I can say, the shape of liquid changes depending on the shape of its container. එහෙනම් යාගේ ලක්ෂණය ඒක තමයි. එයා හැමතිස්සෙම තමන්ට පාවිච්චි කරන භාජනයේ හැඩය ගන්න. එහෙම තමයි ඉගෙන ගත්තේ නේද? මේක පොඩි කාලේ බේසික් ටෝක් එකක් අසුන්. එහෙම දෙයක් ඉගෙන ගත්තද?
Yes, sir.
Right. And so we are going to consider now the variation of pressure depends on depth of the fluid of its container. දැන් ආදිත්‍යගේ විදියට liquid තියෙන්නේ containers වල. අපි කතා කරන්නේ දැන් ද්‍රවය ගැන. මේවා තියෙන්නේ containers වල. And containers, we can find the variation of depth. Right? So let's have some fluids inside a container. When container එකකට දාමු once the way Aditya explained. Now this is the container. And once you insert liquid to here, so it basically takes the shape of the container. දැන් අපි මෙන්න මේ level එකට වෙනකන් දානවා liquid. So Aditya, is it okay? Now the shape of the container is shape of the liquid is the same as the shape of the container, right? So Kasun and Aditya is here. Right. Is it okay?
Okay, sir.
Right. So let's suppose, Kasun, the height of here is h. And the area of this particular side is A. අපි නිකන් එහෙම මේ මෙතන area එක A කියලා ගන්න. Right? And the weight of this liquid is mg. W equal mg. So we have one value so-called atmospheric pressure. So always we have atmospheric pressure. I forget to tell one thing when I defined the pressure, which is force into area, and the unit is Newton per square meters. Or we define this one as Pascal. So always we have atmospheric pressure. අපිට මේ හැමතැනම atmospheric pressure එකක් තියෙනවා. So we basically define atmospheric pressure nearly 1 into 10 to the power minus 5 Pascal. මේක තමයි atmospheric pressure එක ආසන්න වශයෙන්. So top of the liquid we have atmospheric pressure. අපිට මෙතෙන් වෙනකන් තියෙනවා atmospheric pressure එක. So now what we are going to find is that the pressure of this particular point which is here. අපි දැන් ඔන්න දැන් pressure එක මෙතන හොයන්න හදන්නේ. H ගැඹුරකින් තියෙන. Right? H ගැඹුරකින් තියෙන තැන pressure එක හොයන්න හදන්නේ. Is it okay? මේක තමයි අපි දැන් හොයන්න හදන්නේ. So suppose the density of this liquid is rho. Density of this liquid is rho. Right. So Kasun and Aditya. So are you there?
Yes, sir.
Right.
Yes, sir.
Okay. Right. So is it okay if I write W equal mg? So it's a weight. Weight is mg. Is it okay? Mass into gravitational constant.
Okay, sir.
Right. Then how we can write mass with this information? We have rho, we have A, and we have H. So using this information, how to write mass? So let's suppose the volume of this liquid is V. Then how to write mass? අපි M කියන එක්කෙනාට කොහොමද ලියන්නේ? Volume එක V. එතකොට density is rho. How to write this one? Can we write as rho V? M කියන එක්කෙනා rho V කියලා ලියන්න පුළුවන්ද? Asun or Aditya, rho is density. ඝනත්වය. V is volume, පරිමාව. ඝනත්වය වැඩි කිරීම පරිමාව කියලා ලියන්න පුළුවන්ද? Right. So rho is equal to m divided by V. දැන් පුළුවන් ද අපිට ලියන්න? ස්කන්ධයේ බෙදීම පරිමාව. එහෙනම් m කියලා කියන්නේ rho V. Right. So we can write this one. And then we have G here. Now can we write V considering A and H? අපිට ලියන්න පුළුවන්ද? V කියන එක න A H වලින් කොහොමද ලියන්නේ? That is area into H and G. So this is the force ultimately we have. This is the force. This is W. W is equal to force. So pressure here is basically caused by W. And then we have to divide this one by A. So pressure, as I said, that it is equal to atmosphere pressure plus pressure due to this liquid. So liquid, the weight is rho A H G, so this is G, sorry, G divided by A. So this is equal to P naught plus H rho G. H rho G. So what you have to understand is that if you want to find pressure of depth of any depth, let's say H, and the pressure is atmospheric pressure plus H rho G. So rho is the density of liquid, G is gravitation, H is any height. So you can define this particular equation, P naught plus H rho G, right? So you can write this one now. If you have any question, you can ask now.
Recording stopped. Recording in progress.
right ළමෙක් අහනවා ඇයි මේක එකෙන් බෙදුවේ කියලා. එතකොට මේ තියෙන පුතා අපි ගන්න ප්‍රෙෂර් එක කියන්නේ ෆෝස් එක බෙදීම වර්ගඵලය. එතකොට ෆෝස් එක කියලා කියන්නේ මේ වෙලාවේ weight එක. නේද? මේ පහළට තියෙන දැන් අපි කෙනෙක් අපි ඉගෙන ගත්තා මේක. අපේ බොක්ස් එකක් තියෙනවා බර මෑස් එක m නම් අපි මේ පැත්තට තියෙන ෆෝස් එක විදියට ගන්න mg. නේද? එතකොට මේ වෙලාවේ මේ mg තමයි මෙයාගේ ෆෝස් එක වෙන්නේ. ෆෝස් එක බෙදීම ඒරියා එක තමයි මේ ඇවිල්ලා තියෙන්නේ. ඒක අපි ඒකයි ඒ වලින් බෙදුවේ. ආපහු. ඒ වගේ මොනවා හරි ඕනම ප්‍රශ්නයක් තියෙනවා නම් අහන්න. දැන් මේ ළමයි ටික කතා කරන අඩු නිසා තමයි මම වැඩි මේ ප්‍රශ්න මේවා කරලා අහන්න නැත්තේ. මොකද දැන් එන්න ළමයි කතා කරන ප්‍රමාණය අඩුයි. So I can find some discrepancy in this particular batch also. The last batch student talk more, and then that about that batch they talked well, but now it's very less. They are not responding well. Right? ඒක නිසා මම පොඩ්ඩක් මේවා දැන් shift කරලා වගේ තමයි යන්නේ. Otherwise, that there's story behind these things, and we are talking a lot of stories, practical applications, but not now. It's really hard, right? So even now the participation is a little bit poor, right? Only 75 students. Right. So hope this is clear, right? So this is considering the pressure of at h height. Right, then we'll move to a very important equation. This is so-called Pascal's principle. අපි pressure කියන එක දන්නවා අපි equation එකට යනවා Pascal principle එක. Right, so I'll get picture for this one. Right, this is so-called Pascal's principle, and let me explain this one through this particular So what happened in the case of Pascal's principle? Now you can see there's fluid, of course, it's a liquid available in this type of setup. The setup setup, so in this setup, you can see one, of course, two inputs, or I can say two outputs. So I can consider one is input, one is output. So here that we have area 1, which is smaller than area 2. So area 2 is larger than area 1. So in Pascal principles, we can write equation F1 divided by A1 is equal to F2 divided by A2. F1 divided by A1 is equal to F2 divided by A2. So this is so-called Pascal principle. මේක තමයි එතකොට Pascalගේ principle එක. ඒතර මේ වගේ තියෙන තැන්වල අපිට Pascal's law එක apply කරන්න පුළුවන්. ඒකෙදි කියන්නේ මෙන්න මේ වගේ scenario එකක්. ඉතින් මම ඒක theoretically explain කරන්න ලොකුවට යන්නේ. So you need to know only the equation. So this type of place you can apply this Pascal's principle. So what happened here? So what is the meaning of this F1 divided by A1 is equal to F2 divided by A2? Important thing is, this is what we have learned right now. The pressure, which is in same level, I can say, and this is equal. It means that pressure of here is equal to pressure in here. So then we can define this one. ඒකනේ වෙලා තියෙන්නේ. ප්‍රෙෂර් එක සමාන වෙලා. ඒක නිසා තමයි එතන ඒක equal. So pressure stays the same on both sides. So what happened here? The force get multiplied. Force එක multiply වෙලා තියෙනවා area එකට proportionally. මම හිතනවා ඒක තේරෙනවා ඇති කියලා දැන්. For an example, let's suppose this case. අපි මේ case එක පොඩ්ඩක් බලමු. So area is twice. So pressure stays the same, but both sides, the force get multiplied by on the right because of the area is twice as it's to the left. So this is twice. දෙගුණයක්. So the force එක then දෙගුණයක් වෙලා තියෙනවා. ඕක තමයි Pascal principle කියලා කියන්නේ. So I'll allow you to draw this one, and if you need, you can just write that twice. Right? Hope this is clear. Pascal's principle.
Recording stopped.
Right. කලින් සමීකරණේ P නෝට් කියලා කියන්නේ වායු ගෝලයේ පීඩනය. මොකද ඕනම තැනක දැන් අපි හිතමු මෙන්න මෙතන කියලා. දැන් මෙතන ප්‍රෙෂර් එක ඩිෆයින් කරන්න කළොත් අපිට එන්නේ වායු ගෝලයේ පීඩනය ප්ලස් මෙන්න මේ H rho G. ඒ වගේ. ඒතර වායු ගෝලයේ පීඩනය අඩු හැමතිස්සෙම ඇඩ් වෙනවා. එහෙම තමයි අපිට එන්නේ. දැන් ඔයා පීනනවා නම් ගඟක ඒතර ඔයා මේ හරිය හිතන්නේ යට ඉන්නේ කියලා. නැත්නම් මාළුවෙක් කියලා හිතන්න මෙතන ඉන්නේ. එයාට තියෙන්නේ මේ පීඩනය ප්ලස් වායු ගෝලයේ පීඩනය. right? ඒක තමයි එයාට තියෙන පීඩනය. මේ total පීඩනය. එතන තියෙන පීඩනය. මේක H rho G. මේක P naught. P naught plus H rho G. ඔව් මේ ළමයෙක් අහනවා ප්‍රශ්නයක් වායුගෝලයේ පීඩනය උඩට යන්න යන්න වැඩි වෙනවා නේද කියලා. ඇත්තට මේක වෙන්නේ අනිත් පැත්ත. වායුගෝල පීඩනය උඩට යන්න යන්න අඩු වෙනවා. දැන් ඒකට හේතු දෙක තුනක් තියෙනවා. ඒක ඔයාලට සමහරලාට මේක එච්චරම තේරෙන්නේ නැති වෙන්න පුළුවන්. එකක් තමයි දැන් මේ ඩෙන්සිටි එක එයා එකේ මේක මේ සර්ෆේස් එක ළඟ වැඩි උඩට යන්න යන්න අඩුයි. ඒතකොට දැන් එතෙන්දි මතක තියාගන්න රෝ කියන වැලියු එක ඇත්තටම අඩු වෙනවා. එතකොට වෙන්න පුළුවන් දේ තමයි මේ රෝ වල අඩු වීම නිසා මේ මෙතෙන්දි වායුගෝල පීඩනය අඩු වෙනවා. ඉතින් ඒක තමයි මේන්ලි වෙන්නේ. අපි සාමාන්‍යයෙන් කියන්නේ the air become less dense. එතකොට ඒක නිසා යා ප්‍රෙෂර් එක අඩු වෙනවා කියන එක තමයි ඔයාලට දැනට ඉගෙන ගන්න. තව ගොඩාක් පොයින්ට්ස් ටිකක් තියෙනවා මේකට මේ සම්බන්ධ වෙලා. ඉතින් බේසිකලි යා ප්‍රෙෂර් අඩු වෙනවා. රයිට් ඒක තමයි මේ අපිට දැන් ගන්න තියෙන්නේ. ඒ ප්‍රෙෂර් එක අඩු වුණාම තමයි සමහරවිට අපිට අර හුස්ම ගන්න අමාරු වෙන දේවල් ඒවා වෙන්නේ. ඒ වගේම තව ගොඩාක් ප්‍රශ්න වෙන්නේ. දැන් ප්‍රෙෂර් එක අඩු වුණාම තමයි මේකේ තියෙන මේන් ප්‍රොබ්ලම් එක වෙන්නේ. එතකොට P1 ගොඩාක් යටින් තිබ්බොත් P2 සයිඩ් එක ගොඩාක් උඩින් තිබ්බොත් මේ සමීකරණේ නෑ මේ සමීකරණේ හරියන්නේ නෑ. එතකොට මේ සමීකරණේ හරියන්නේ ඒ වෙලාවට විතරයි දාන්නේ අපි. මේ එතකොට දානකොට වෙන දේ ඊට පස්සේ වෙනවා. දැන් මේක අවස්ථාවක තමයි මේ සමීකරණේ වැලිඩ් වෙන්නේ. ඒ අවස්ථාවට තියෙන force එක calculate කරන්න. So you can learn this one. I'll give you certain examples, then you can clearly understand this one. මේක හැම උඩට ගියාට පස්සේ අපෝ සමීකරණේ වැලිඩ් වෙන්නේ නැහැ. මේ වැලිඩ් වෙන අවස්ථාව තමයි අපි දැන් පාවිච්චි කරන්නේ. right ඒක තමයි condition එක. ඒතර මේ condition එකේදී force එක අපි measure කරනවා. අන්න එහෙම එකක් වෙන්නේ. right?
Recording in progress.
Good questions, of course. Right. So this is a condition basically. This is P1 equal P2 situation. Right. Then this equation is valid. Then we can calculate. So let's consider some examples. Now let's suppose this case. Right. We have equal area. So equal area means the force is equal. Right? So because the force divided by area, which is pressure, then force divided by area, which is pressure. So this is what Pascal principle said. So let's suppose we have this type of situation. Now we have large surface area on the right side and then small surface area in left side. So force divided by area is should be equal to the force divided by area in right hand side. So this is a large force divided by large area. So here you can understand we have a larger force. So this one gives large force if you have a large area. So this is happening especially in automobile industry or even the mechanical industry. We are using this particular principle, especially that operating in hydraulic pumps. Hydraulic pump එක වෙන්නේ මේ වගේ පොඩි වැඩක්. So even if you go to some school exhibitions, you can see that our students are using syringes and then operate some of the construction machines or that some robotic arms using this one. So this is using in everywhere, and even in vehicle jack that we are using, the same principle. So we have a large force, and we can use this large force to lift some vehicles. So here we are using compression, and we have small area there, and we apply small force, and we have a large force, and we can define that one. So it's a hydraulic lift, and this type of hydraulic lift, you can understand that apply very small force, and F2, then which is very large, and then you can do some work there. So we are applying a Pascal principle in the same level. But once you apply this one, this will do certain movement. For an example, once you apply small force and to small area, that is understandable. But this particular liquid level will move far away, D1, and here it's only a small distance, D2. Because we cannot basically violate the energy conservation. Energy conservation can violate කරන්නත් බෑ. Right? So what happened here, the F1 D1 is equal to F2 D2. That is also true. So that is why that D1 is larger than D2. Here that F2 is very much larger than F1. So that is why we can lift the vehicle. But please do understand that we have to move this cylinder or the compressor little bit more compared to what we can get in F2 side. F2 side එකේම ගොඩාක් උඩ යන්නේ නැහැ. එයාව ගොඩාක් උඩ දාන්න අපි පොඩ්ඩක් වැඩිපුර move කරන්න ඕනේ. ඒක තමයි මෙතන ඇත්ත කතාව. Right? So hope this is clear. මේක මම හිතනවා පැහැදිලි කියලා. So let's do one question here to understand this one. This is the example. So we have hydraulic lift, right? And then large cross-section area and small cross-section area. So let's suppose that large cross-section area is 20 times larger than the small one. 20 times larger than the small one. And we are giving F1, which is 25 Newton. 25 Newton කියලා කියන්නේ කිලෝ 2.5ක පොඩි බරක් තියන්නේ. So let's find what is the output force, F2. F2 කීයද? So F2 is 500 Newton. It means 50 kilogram. Kilogram 50ක බලයක් අපිට එහා පැත්තට දෙන්න පුළුවන් මේ වගේ system. So we are using this one everywhere. Right? So you can see this hydraulic pump usage in everywhere. පීඩනය වැඩි වෙලා මේ නල පුපුරන්නේ නැද්ද කියලා අහනවා. ඉතින් ඒව වෙන්න පුළුවන් දේවල්. Right? So that is why that you can understand the compressor. Compressor wall is very thick, so that is why that because there might be possibility that getting high pressure there, right? That's true. Right. Hope this is clear. මම හිතනවා මේක දැන් තේරෙන්නේ නැති කියලා. Right. So you can draw this one and you can get certain idea about what happened here.
Recording stopped. Recording in progress.
Right. Any questions? මොනවා හරි තියෙනවද ප්‍රශ්න? ඉතින් මේක use වෙනවා හැම තැනම වගේ applications වල. ඉතින් ඕගොල්ලෝ මේක කවදා හරි use කරයි ඕගොල්ලෝගේ final year project and something like, then you can remember the physics here, right? So using in many occasions, even in vehicle braking system, we have a similar way. And if you go to, let's say, see the dental doctor, and there you can get the dental chair, which is moving in same way. So dental doctor is move you just applying the pressure through his foot. අපි දන්නවා ඩොක්ටර් මෙහෙම වාඩි වෙලා ඉන්නවා එක තැනක. වාඩි වෙලා එයා කකුලෙන් තමයි පාගන්නේ අර පැඩල් එක. මේක මෙහෙම පාගනවා. පාගනකොට so you are basically sitting there and so your chair is moving upside. So it's your weight and also the weight of chair. So he has certain paddle here. The area of the paddle is very small. පොඩි knob එකක් තමයි තියෙන්නේ. So area of this one is very high. Very large area. එතකොට මේ system එක වැඩ කරන්නේ අන්න මේ විදියට. එයා pressure එක දෙනවා. ඉතින් මේ වගේ ඕන තරම් applications තියෙනවා. I hope that you all can understand. Right? Right. So I draw that dental array case, right? So you can get many applications, right? So you can see that this type of application. You can see that very small area here. So it's applying pressure and then moving this particular heavy weight to upper side. And even vehicle system, you have a similar situation. So you're applying brake for the moving tire. And here that you have a very small area. So everywhere it's same. Or even school project, you can see this type of things students are making. Right? I hope it is clear for you all. Right. So even the syringe, we are having similar situation. We are extracting large pressure here. Right. So hope this part is clear, and you can search. You can search in internet, and there are videos available in Pascal principles, so you can learn these things. Right. So with that, I'll stop today, and next day that I will do the other part of this fluid dynamics, that is so-called buoyancy force. අපි උඩුකුරු තෙරපුම කියන දේ ගැන කතා කරනවා. And then talked a little about viscosity and then Bernoulli principle. Then we'll stop this fluid dynamics. Right. So that's all for today. And I'll meet in next time. Right. So thank you very much for joining.
Recording stopped.
So if you have any question, you can ask. So next week, Wednesday to Sunday, I'm not available. So I can do one lecture Monday morning, 11 to 12. Right, Monday morning, 11 to 12, I will do another lecture. So is it okay for you all?
Sir, there was a CAD lecture on 9 to 12 on Monday.
All right, 9 to 12. So how about 7:30 to 8:30?
It's okay, sir.
Right, so 7:30 to 8:30, I'll do one lecture, right? Next Monday, 7:30 to 8:30, that we'll discuss buoyancy force and viscosity. In that case, that is okay. Because Tuesday, I'll go to Singapore and then return back Monday. So I will not available. I'll try to do lecture next Tuesday, right? Next Tuesday, the other part I will cover. And then we can finish this lecture series as soon as possible, right? Right. Okay, so any other questions? Seems to be no. So can you give a PDF? The answer is no, because I will do a revision lecture, and in that case, you can ask whatever the questions you have. And so complete the note considering what I have taught here. But before the examination, I will upload all the videos, but not now, right? So here that student has to come to the lecture. No excuses, because now it's not the excuse to say that your internet connection is poor. Because everywhere that you can find this connection, and this is even if you move some other places, you can get this connection because you have passed the advanced level examination. It means that you know the technology and you know how to do this one. This is because this is for your future. So for your future, that you have to do this one. Right? Because now the internet connections, those packages are very cheap. It's not expensive at all, right? And everyone is having smartphone. It's really easy for you to join for this lecture. I expect you to learn in that manner. I cannot give excuses for you when you are still in your first year, first semester. හරිද? ඒක නිසා මේකේදී ළමයා හදාගත්තේ නැති වුණොත් අපිට ඒක පාඩුවක්. අපි කරන අසාධාරණයක් ඔයාලගේ දෙමව්පියන්ට. ඒක නිසා මේක එහෙම කරන්න දෙන්න බෑ. ඒක නිසා ළමයා එන්න ඕන ලෙක්චර් එකට. ඒක තමයි වෙන්නේ. එතෙන්දී ඔයා අනම්මනම් සිග්නල් නැහැ, අරක නැහැ, මේක නැහැ කියලා ඒක හරියන්නේ නැහැ. එහෙම ළමයි අපිට හම්බ වෙයි. ඒගොල්ලෝ පර්සනලි කතා කරන්න. So personally, I'll give that video once they are coming here. Right? Okay, right. Thank you very much then.